Here is a very simple Java program. You must have written similar lines of code hundreds of times. Here is the question though. Do you know what happens when this line is executed? Where does this X variable is stored in Java memory? Or do you know where this person object will be created? Or what happens when this modify function is called? So in this video, we are going to look at what happens inside Java memory when this code is executed line by line. Now what we'll do for each line when it is executed, we will show what happens at Java memory by taking a snapshot of Java memory. So Java memory is basically at high level has a two types of areas. There is a stack and then there is a heap. The stack is usually associated with individual thread and it is a last in first out kind of a data structure. Heap is shared by the thread and where usually object lives. Now let's go line by line. So when we are at this first line inside main method, the first thing is that the first stack frame would be created for this main function inside the stack. Then when x equal to 10 is executed, the x would be stored on the stack because the primitive variables are always stored in the stack. So that value would be stored on the stack. Now when next line is executed, there are like multiple things here. So we are creating new person object and call to this new person object also contains another object which is a string object Alice. A string Alice would be created inside heap. Then new person object would be created. Now it has two fields, name and age. Now age would be assigned a value directly as a 20. And this name variable would start pointing to this object Alice. Now here is the interesting thing. Now even though age is primitive, since it is part of object, it would be still part of heap. So there is a difference when primitives lives inside a method, it would be created on a stack, but if it is a part of the object, it would live on the heap. Now when the person P is now would be assigned this object. So what will happen? The reference P would be created on the stack and this person P variable would start pointing to this new object. Now let's see what happens when we call this modify. So as we have discussed earlier, whenever this new method call is executed, new stack frame is created. So this current stack frame would not be visible. So this stack frame where P and X equal to 10 lives would not be visible inside modify. Now if you see modify line, you see there is a new variable is introduced, the ref. Now this ref would be created and it will also start pointing to the person object because the P value was passed to this modify method and it is copied to this person ref. And since P was containing the reference to the person object in the heap, the same reference is copied inside a ref. So inside the modify now, we will execute the next line, which is ref.name equal to Bob. If you see here, the Bob is another object. So first this object need to be created on the heap. Then what would happen? Then ref.name would start pointing to this new Bob variable. So this new object, the person would start, person.name would be pointing to this Bob. Now when this callback comes back, this thread or this stack frame would disappear now. And we will be again inside the main method scope. So the stack frame where P and X lives would be visible now. Now you can see this P is pointing to this same object. And now if you try to access the p.name, it will give you the Bob. So what did we learn here? So what we saw is that every method call creates a stack frame. So when we called the method main and the modify, both created a new stack frame. The primitive variables live in the stack. So whenever we create any primitive inside method, those live on the stack. Objects. So objects which are created using new or string object live inside a heap. So we have seen the object that we created and it was stored on the heap. Now these objects are connected to a reference on a stack. So heap and stack are connected using the references which are stored on the stack. And we have also seen when stack frames disappear when a method return. So whenever we call a method and there is a return, that stack frame is removed. So that concludes this visual presentation for stack versus heap. So if you want to see similar kind of video, let me know in a comment about the topics that you want to see visually. Also, if you enjoyed this video, please don't forget to like and subscribe.